Hello, my people. Welcome to our physics class. Now, before we continue, today we're going to be talking about what we call wave. So we'll be talking about what you call wave. Now, let's see exactly what wave is all about. Let's see what wave is all about. First of all, I am going to define to you what the meaning of wave. Now, we all agree, or we can say that wave is a disturbance. Wave is a disturbance. But this disturbance I'm talking about, what kind of disturbance are we talking about now? Whenever you hear the word disturbance, this disturbance we are talking about, what type or what kind of disturbance now? The disturbance we are referring to in this wave is a vibratory system or an oscillatory system. So this disturbance we're talking about, before you say that there is wave, there must be what? Vibration. There must be what? Vibration. Vibration. Or there must be what? Oscillation. So either of these must occur. Vibration in the sense that the particles of our matter or the particles involved will either be going up or down, or the particles are going to and fro, forward and backward. So from this, you will now observe that we have what you call um, transverse wave, though I'm here to explain this. But whenever we go deeper, when we go deeper into this wave, I will explain further the modes of propagation, mode of propagation for this wave. We have what you call transverse wave, and we also have what you call longitudinal wave. Now, coming to this now, in terms of transverse, I'm just explaining this transverse and longitudinal because of this word disturbance. I want you to understand the word disturbance, what it means. You discover that the particles of our matter or the particles involved goes what you call up and down. That is for transverse. The particles go up and down. If you look at your textbook, you must have seen something like this. That is, you have something like this. Assuming this is your rope, this is your rope, and you set this rope into, you disturb this rope, and whenever you hear the word they disturb or being disturbed, it simply means that you set this rope into vibration. Like this rope is going up and down, you vibrated it. So that's what I mean by the disturbance. This is exactly what we mean by the disturbance. And whenever you set this into vibration up and down, that is to say this is under what you call the transverse. It's still under what you call transverse mode of propagation. Transverse. Then at the same time, you can also set your particles into what you call oscillation. Now, let's take for instance, assuming I have these are my particles. These are the air molecule particles, your matter. For instance, these are the particles. We have all these particles now. And I have what I call my speaker. This is my speaker. Assuming I have my speaker now, this is my speaker now. I powered it on. What happened if I powered it on? Let's say I'm playing some music. I'm playing some music. So what happened now? This cone in this your speaker will start vibrating. Like it's going to be going forward, backward, forward, backward. Now, if it is going forward and backward from your speaker now, the particles or the air particle or the air molecules around the cone of that speaker will go what you call, will also vibrate. They will go forward and backward. So what will happen is this particle that is closer to this place, this frame will hit this particle. This particle will now go forward and return back to this original point. Then this one that is being heated will now go forward and also return back. The same thing happened to this one. This one will go forward and hit this particle and return back to its original position. This one will also move forward and return back to its original position, like by hitting this one. So you will now see that the disturbance we're having here is that I disturb these air molecules, and the air molecules are going what? They are going to and fro, and this is known as oscillation. So when you talk about wave, there must be a disturbance. The disturbance is in the form of what? Is either in the form of vibration or in the form of what? Oscillation. I hope you understand what I'm saying. I hope you understand what I am saying. Now let me explain that one more time. Before you talk about there is wave, there must be a disturbance. Before you talk about the word wave, there must be a disturbance. This disturbance can be in this form. It's either in the form of what? Vibration, whereby the particles of the matter are going up and down, like the one I showed you here. This is my rope. I vibrated this my rope, or I disturbed this my rope, or I set this rope into a wave, like into, yeah, vibration. So what happened now? This rope will be going what? Up and down. Okay, let me give you another example of this scenario. Assuming you throw in, you drop stone inside a water container. What happened to the water container? You discover that the water will vibrate. Vibrate in the sense that every particles in that water will continue to go up and down. You see something like this in the water. Though if you look at it, you will observe that it's going to be appearing circular form, but you see the particles will be going up and down, which means that you have disturbed that water. And how did you disturb that water? You set that water into vibration. And when the vibration is going up, the vibration is spreading. It's not going to be at the original point again. It's continuing to spread. That's when you see this circular form coming up and, spreading. The circle continue to spread. So you see, it's the energy or the vibration will continue to spread. Now, since I've explained to you, since I've told you that wave is a disturbance, but the disturbance is not going to end at vibration or oscillation. Before you say that is a before you call it wave, um, this disturbance is not going to end there. Rather, they say that this disturbance will do what now? Is a disturbance. Wave is a disturbance which travels. This disturbance must travel through a medium, which travels through um, through a medium. It must travel through a medium. So, like I explained before now, this disturbance we're talking about, which is in form of either vibration or oscillation, must occur in a medium. It must travel through a medium, transferring energy, transferring, transferring energy, transferring energy from from one point, from one point to the other. So when you talk about this now, this disturbance must travel through a medium, and whenever it's traveling through a medium, it must transfer energy from one point. It must transfer energy from one point to the other. It must transfer energy from one point to the other. Like I explained before, assuming you dropped stone inside the water, you discover that you see this continue going. That's why you see something like a circular form. Or even if you use this analogy I used here, which is your speaker, you discover that your speaker will always vibrate. Whenever it is vibrating, it will vibrate the nearby air molecules around it. And whenever this air molecule around the cone of this speaker vibrate, it will now hit another air molecule. That is, it will now set another air molecule into vibration, that it will hit it and return back. The air molecule, that this molecule will now have a momentum or energy to do what? To hit another air molecule and return back. This one will also have energy to do what? Hit another air molecule and return back. You will now see that this energy is being transferred. Initially, it was within this cone. This cone now hits this air molecule. This air molecule now does what now? Hits the next air molecule and return back. So this energy, or the energy, is being transferred from what? From one point, which is from here, to what? To another, from here to here, from here to here, from here to here. It continues. This one will hit another air molecule now and return back to its original position. Now this one will now possess energy, like it will have energy to move and hit another air molecule and return back to this energy. So you see, it continues. So the energy is being transferred. You see, it continues to transfer, continue to go. That's it. Now they say that this travels through a medium. It has traveled through this medium, transferring energy from one point to another without, without causing, causing any, what? Permanent, permanent, permanent displacement, displacement, displacement of the medium. And what does that mean? Like I told you before, these air molecules are being vibrated in the sense that they will hit this air molecule. Let's say this frame now, this is a cone, hit this air molecule. This air molecule now hit this one. Now, whenever this one moved from its original position to another to a distance to hit another air molecule, what happened now? It will hit it and return back to its original position. That is what I mean by without causing any permanent displacement. The air molecule was displaced, but it returned back to its original position. So that's what we mean by it does not cause what permanent displacement of what the medium. Now, since we have already known what the wave is all about now, let's look at source of wave. Let's look at what you call the source of wave. Source of wave. Let's talk about what you call source of wave. Where is this wave being produced? This wave is produced from where? Where exactly is wave being produced? Now, from what I defined to you, wave is produced from what you call a vibrating what system. So what gives us wave is what? Vibrating system. The system must be in vibration or an oscillatory system, or the system must be what? Um, Oscillating. So wave is produced from what you call what now? From a wave, source of wave. It is from what you call what? From a what? From vibrating, vibrating what? System or oscillating system. So wave is produced from what you call a vibrating what? System. And wave. And what exactly do we know wave as now? Wave is a mode of what? Energy transfer. So whenever this system is vibrating, or whenever this system is vibrating now, energy is being what? Transferred. Remember, a vibrating system that does not transfer energy is not wave. Before you can name it or before you can say it's a wave, the vibrating system must do what? Transfer energy from one point to what? To another. Before you can now name it what? Wave. So that's why I say that when you talk about the mode of what? Energy transfer. There is only one thing that does energy transfer, and the only thing that does energy transfer is what you call what? Wave. So wave is a mode of what? Energy transfer. It does what you call energy transfer. Now, since I've explained to you all this in now, and I've already told you that wave is a disturbance. And this disturbance we are talking about is either a vibrating system or an oscillating system, which does what? Travels through a medium without causing any what? Travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. Now, since you have already known about it now, how about we talk about what we call wave motion? What is wave motion? So let's see what wave motion is all about. Wave motion. Let's see what wave motion is all about. Let's explain what wave motion is all about. Now, I want you to do me a favor. The only thing I need you to do now is anytime you are listening to what I'm saying, I would like you to take notes. Just write out all this information that I'm saying, because the more you write, the more you understand what I'm saying. Now, let's continue from what you call wave motion. What is wave motion? Wave motion is the process, is the process of um, transferring, the process of transferring energy, energy from, from, from one point to the other without causing any permanent permanent displacement of the medium. To me, sorry. So Wave motion is the process of transferring energy from one point. That process of transferring energy from one point to the other without causing any permanent displacement. I've explained that before. That let's use what you call the air molecules again. Let's use air molecules again. As I have air molecules like this. These are my air molecules. They are invisible. I'm not seeing them actually, but I'm going to explain to tell you how things really work. Now, assuming I set this particle, like I told you before, I set this particle into like this particle gets or gains energy to do what? To move. This one move. Hit this one and return back. Hit it and return back. That is, you will now discover that the energy has been transferred. It was transferred from this person to this particle and it went back. Now this one is now in possession of that energy. This energy is being transferred. This one will hit this one and return back to its original position. This one will now possess energy to do what? To move forward and hit the next particle. Likewise, all these particles, these are the things that are doing now. Now you will now observe that this energy is being transferred. Where was it before? Here, that was the initial point. And where is it now? Here is the final part. So this energy was transferred from here to what? To this place. And when this is going on, the particles that are involved only does what? They only hit the next particle and return back to their main position or the original position. So that's what we mean by they do not cause what we call permanent displacement of what? Of the medium. Now, can we now differentiate between wave motion and what you call particle motion? Remember, in terms of anything called wave, there must be what? Either vibration or what? Oscillation. But that's not the only thing that you need to know. What else do you really need to know? Apart from vibration and the oscillation, energy must be transferred. Before you can call it wave, energy must be what? Transferred from one point to what? To another. So there must be what? Transfer of energy from one point to what? To another. So that's it. So, but in a summary, I need to say something now before I talk about. Okay, let's talk about what you call the difference between wave motion and what you call particle motion. What is the difference between wave motion and that of what? Particle motion or motions of particles. Now, let's look at the difference between wave motion and particle motion. The difference between what you call, we have what you call wave motion, we have what you call wave motion, and we also have what you call particle motion. Yes, we have what you call particle motion. We have wave motion, we have what you call particle motion. Now, we can just, please forgive my drawing. Forgive my hands are not really straight. I don't know. It just decided not to be straight this evening. Oh, please, don't mind me. Okay, now let's look at this now. What's the difference between wave motion and particle motion? Let's look at the difference between both of them. Number one, what did I say that wave is all about now? I say that wave is a disturbance, and disturbance is in form of what? Is in form of what? Vibration, or let's say vibratory or oscillatory. So this is what you call vibratory or oscillatory. So wave motion always do what? Vibrates, or they do what? Oscillate, which means the particles of our matter involved in this, or the particles of the medium involved here, either does what? Either goes up and down, or they do what? Go to and fro. So the particles of the medium involved does only these two things, either up and down or to and fro. Unlike your particle motion. Particle motion does what you call what now? Translational motion. It does what you call translational motion. Translational motion in the sense that it can go from one point to another in a straight line. It does not necessarily need to do what? Vibrate, that go up and down. It does not necessarily need to do what? Oscillate. Oscillate simply means that it must go forward and return back. To, through, to, through. Vibrate means that it must go up and come down, up, down, up, down. But for translational, it just simply means that the body can just move, the particle can just move from point A to B without returning back to this original position. If it does, it's going to be oscillatory. So this is translational. The particle move in a straight line from point A, from this point to another point. So it's not going to return back. That is, particle exhibit what you call translational motion. That's not the only motion that it does. It also exhibits what you call rotational motion. Rotational motion. So particles can also a particle in a rotational what motion. So it means that it can go revolve around, like go around, where like it's going to be in a circular form. Now, but where wave motion doesn't do that, then it can also do what? It can also oscillate. Yes, it can also oscillate. Oscillate in the sense that it oscillates, oscillatory, or it can even vibrate. Yes, it can also vibrate, vibratory. So you see that particle has the features. It can translate. It can do what? It can undergo translational motion, rotational motion, oscillatory or vibratory motion. Then it can also undergo what you call random motion. These are basically the four types or the whole types of motion, random motion. Unlike your wave, wave can never undergo translational motion. It can never undergo translational motion. It can never undergo rotational motion. It can never undergo random motion. Rather, wave can only undergo what you call oscillatory motion or what vibratory motion. So that is for your wave. But for your particle can undergo all of them. Okay, that's it now. Then number two, another difference between um, wave motion and particle motion is that motion without the bulk masses, we have this one known as motion, motion, motion without without the the bulk masses. And what does this mean now? It just simply means that a particular part of the medium will be vibrating. It will only vibrate. Then transfer that energy from that place it vibrated to the next particle of the medium. So all the medium does not vibrate at the same time. They do not oscillate at the same time. That's exactly what wave motion is doing. So wave motion, all the particles involved, assuming you have this your water, assuming you have your water, all the particles does not, I mean, they do not do what? They do not vibrate, oscillate at the same time. But unlike your particle nation, your particle motion can do what? Motion with it is a motion with bulk masses. Everything can vibrate at the same time. So let's see motion with the bulk masses. Motion with the bulk what? Mass. Yes, the whole mass might vibrate at the same time. Then number three, we have your wave motion exhibits has features. It can show the following features now. It can also show all the features of all the properties of wave, which includes, so let's say it exhibits what? It exhibits what you call reflection. It exhibits what you call reflection. It can refraction. What again? Diffraction. And what again? And interference. And interference. Wave can do this. But for your particle can do everything without what now? No interference. Without interference, it can exhibit all this property, but not for interference. So for no interference. Now, before I talk about this, before I go over what you call terms we use in our wave, I would like to go over the general features or the features of wave again once more so that you understand the features or the characteristics of wave or the features of wave or properties of wave, what wave are being known for. So let's look at this now in a general sense. Let me just call it properties or features of wave. Let's see, let me call it features of wave. What are the features of wave? Now, like I told you before, what are the various features of wave? Number one, waves are produced by what? How do we produce wave? Waves are produced by what? By what? Okay, tell me. I'm listening. I'm listening. So tell me, how are waves being produced? They are being produced by what? Vibration. by vibration or oscillation. Okay, I can say vibration or vibrating system. Vibrating what? System. Vibrating system. Vibrating system. That is how we produce wave. So wave are being produced by vibration. That's number one. Number two, what again or is the feature of wave now? It must do what? Transmit energy from one point to another. Transmits what? Energy. It must transmit energy from one point to what? Another. So transmit energy along the medium. Transmit energy along the medium. So it transmits energy from one point to another. So that's what I mean by it transmits energy along the medium. So it must transmit energy. Now, number three that you need to take note of is that particles of a medium vibrate with the wave motion without the entire medium. So the same thing I told you, it's going to vibrate without causing any permanent displacement of the medium. So let's see, I said particles, particles. I hope you're writing down this. Hmm? I'm just looking at you. I hope you're writing it down. You better do so because the more you write, the more you understand. You're going to have what you call eye-hand coordination. So the more you write, the more you master it into your memory without you even knowing that such a thing occurs. So now, particles of a medium vibrate with the wave, with the wave motion without the entire without the entire medium. Okay, so that's it. Then the last feature that we have is that some some um some wave require material medium while some does not. So some require material material medium for their propagation. For them to be carried out, they need material medium. Some requires material medium. Some? Why some do not? Do not. So these are the pictures, or these are the, let's just say, summary of everything that you need to know about wave. These are the summary of everything you need to know about everything you need to know about wave. So I'd like you to take note of this now. How is wave being produced by? That is source of. I'm asking you that based on source of wave. Source of wave. That wave is being produced by what? Vibration. Another feature is that it transmits energy. Now another thing is that there will not be what? Permanent displacement of the medium, and some require material medium while some do not what? Require material medium. Okay, now I would like this class to be very brief, so I'm not going to waste too much of your time. So the next thing I'm going to talk about is what you call terms in wave. So the next thing we're going to talk about is what you call terms in wave, or wave terms in what? In wave. So these are the various things that we're going to talk about now. So we have the various terms as number one. We have what you call amplitude. Amplitude. We have what you call amplitude. Now, amplitude, normally, if you want to represent, or if you want to represent your wave, we always represent wave graphically by this process. Now, we can represent that something like this. You can use something like this to represent our wave. Now, and this is our main position. This is our rest position. Here we have here to be 0. Here, all these places could be any number. It could be 90, could be anything. So now when you talk about the first one, we have what you call amplitude. Amplitude is the maximum. It's the um, maximum displacement, maximum displacement, maximum displacement from the rest position, from from the rest position. Now, whenever you are whenever you're told that amplitude is the maximum displacement from the rest position. Rest position is this place that I wrote 0. This is your rest position. Now, if you measure from here, from your rest position to this place, this is not the highest height that you're going to get. I think this is going to be the highest. If you measure from here to here, this is the maximum or the highest height you're going to get. And from here to here is known as what? Amplitude. Now, amplitude is measured in what? It is measured in meters. It is measured in what? In meters. Meters, M. So it's measured in meters. Then number 2 is what you call crests. We also have what we call crests or trough. Crests or trough. Now, this crest or trough we are talking about is the maximum or minimum position in transverse wave. Minimum, maximum minimum positions in transverse. Oh, I can't even spell transverse again. Oh, please forgive me. This is going to be transverse. Okay, in transverse what? Wave. So where do we exactly have what you call crest or trough? We only have crest or trough whenever the particle or whenever the wave is in vibration, going up and down. Like this one, we have up and we have down. So we have up and we have down, up, down, up, down. So from here, this place is the maximum position. This is the maximum position. And here is called crest. And here is your what? Your minimum what? Position. And here is called what? Trough. Okay, so let's look at one more term before I wrap it up, because I would like to continue with this term in my next class. So before I wrap it up, because this class is supposed not to be lengthy, so the next one is what we call compression and rarefaction. Compression, compression, and what? And re okay, rarefaction and rarefaction. This is your C. This is your C. Compression and rarefaction is the maximum or minimum maximum or minimum position in longitudinal wave, in longitudinal what? Wave. So in terms of this now, we also have what you call we also have what you call compression and rarefaction. Now this is exactly what we meant. When I was saying, so I was giving analogy using what you call sound wave, whereby I told you that these are the particles. This particle will now hit each other. When this particle comes closer to hit this one, like when they are coming closer now, it is going to be called compression. We call it compression. And when they are coming together, let's say this one is coming together to this one, there might be space. There is going to be a very huge space between those of them that are coming together and those of them that are yet to come together. So these ones that are yet to come together, are known as what? Rarefaction. Rarefaction. So you see, the air molecules are being together, we call it compression. Then, spaciously enough, we call them what? Rarefaction. And I say that this is the maximum or minimum position in what? Longitudinal what? Wave. So where we see compression and rarefaction, we only see that in what you call longitudinal what? Wave. I will still explain what you mean by transverse wave and what you call longitudinal wave. Remember, I once told you that wave has to do with what? Disturbance. And this disturbance could be what? Vibratory, like up and down, because transverse does what you call up and down movement, while longitudinal does what you call oscillatory movement, which is to and fro, up like to. This one is coming, this one is spacious, and this will come and go back. So what happened here is what you call longitudinal wave, whereby the particles are going forward and backward, forward and backward. So that is it. And you know, normally this is the direction of the wave. The wave are going like this now, and the particles are going forward and backward. Instead of them to be going up and down on top of the direction, the way they are going, rather they are going forward and whenever something is going forward and backward, parallel to the direction of the wave, we call it longitudinal wave. But when that same wave is going what you call perpendicular to the direction of vibration, so to the direction of propagation, we call it what you call transverse wave. Remember that this oscillatory and vibration I've been talking about are known as the disturbance. And these disturbance are part of what you call wave. Now, without wasting most of your time, I would like us to continue from terms in wave in our next class. Now, before I leave, do well by subscribing to this channel. Click on the notification bell so that you will be notified when next we upload our next video. Okay, so this class is basically meant for all those of them in preparing for your JAMB, your WAEC, or those of them in SS2, or those of them in year 1. So if you're in any of this category, just listen carefully to this. So you are going to get a lot of knowledge from it now. All right, thank you. See you next time. Peace out.